The Multiverse Revealed, Episode 4.
The Code of Reality. Quantum Computing and Parallel Universes.
What if your next search result isn't found here, but sifted from 1,000 neighboring worlds and braided back into one answer? What if every quantum calculation is a choir, and interference is how the multiverse learns to sing in unison? Tonight, we open the black box and read the code that reality runs. A quantum computer doesn't just crunch faster, it computes differently. Where a classical bit is 0 or 1, a qubit can be both, until a choice is forced. Entangle many qubits, and you don't merely hold many numbers, you hold many histories in superposition. The trick is to choreograph those histories so that wrong answers cancel, and the right answer interferes with itself to stand tall. In David Deutsch's framing, this isn't poetic license. Quantum theory is the physics of the multiverse, and parallel universes affect one another only weakly, through interference. Take the equations literally, and the cleanest reading of experiments is that reality contains vast numbers of parallel worlds, whose ghostly crosstalk shows up in interference patterns. Quantum computation then becomes a controlled weaving of branches. Let alternatives unfold, then make them meet, so that only the solution survives the collision. That's not faster abacus, it's a distinctly new way of harnessing nature.
1. From bits to qubits, the room where futures gather.
A single qubit is like a coin still spinning. 2 qubits are like 2 coins spinning together, their fates linked so that calling one fixes the other. With n entangled qubits, the computer holds an exponential orchestra of alternatives, but power lives not in the number of notes. It lives in how they interfere. Deutsch's stark reminder: the most significant quantum effect is not the quantized pixels of nature. It is interference, patterns that change when you add a path and sometimes make darkness darker. That astonishing more paths, more dark logic is the fingerprint of other branches at work.
2. Interference are computation between worlds.
Open a second slit and some points on the screen go dark. The particle's other history cancels its chance of landing there. In Deutsch's telling, no copy is privileged. Each you in each branch feels tangible, and yet their combined influence writes one pattern. That's the seed of algorithm design in quantum land. Arrange the evolution so that the wrong paths cancel and the right path is amplified. Think of a hallway of mirrors. Every route you might walk reflects through the hall. Set the mirrors just so, and all the wrong reflections vanish in darkness. One route is left glowing. You don't brute force the maze, you tune the hall.
3. What quantum computers actually unlock.
Period-finding factoring, Shor, exploits structured interference to unwrap periodicity, slashing problems once thought intractable. Amplitude amplification, Grover, aim the spotlight so an unstructured needle is found in fewer pulls. Simulation, chemistry and materials where classical memory explodes are native to qubits. Deutsch's thesis is bolder than speed-ups. Some computations are impossible, even in principle, on classical Turing machines, but feasible on quantum machines because the resource tapped is interference itself.
4. Why your table doesn't evaporate, the quiet background miracle.
Even your desk is a quantum feat. Under purely classical laws, arrays of charged particles would disintegrate chaotically. Only quantum interference across parallel histories stabilizes solids. Everyday matter is already a success of the multiverse's code.
5. The villain of the lab, decoherence, and how to outwit it.
To read a quantum computation, the branching subhistories must re-meet cleanly. If the evolving branches leak into the environment, air, heat, stray fields, the meeting happens everywhere at once and the signal is washed out. That is decoherence. Not fragility for its own sake, but the computation's effect on the world spoiling the final interference. Error correction codes, shielding, and clever encodings are ways to keep branches coherent until the last beat.
6. Universality limits and why reality is layered for self-access.
Computation sits at the heart of virtual reality and experience. But not every logically possible calculation is tractable in the world we inhabit. Deutsch argues the laws of physics don't merely allow life, thought, and discovery. They make them efficient enough to arise. Reality is layered for easy self-access. So successive, better explanations and inventions could be found with the resources available. That is why knowledge could grow at all, and why a practical universal quantum computer is physically meaningful.
7. The four-strand worldview and where quantum computers sit.
Deutsch's grand picture threads quantum physics, computation, evolution, and epistemology into one fabric. A quantum theory of computation underlies the classical theory, just as quantum reality underlies classical appearances. In that weave, quantum computing isn't a gadget. It's a window, a way we directly engage the multiverse's operating system.
8. 2 metaphors you can feel.
The school exam you almost failed. Remember the night you stared at the page and nothing clicked, until suddenly everything did. In a quantum computer, countless near answers ghost through the machine. Arranged right, their wrongness cancels. What remains is that click. Your first favorite puzzle. As a child, you traced every path with a pencil. Here, every U in every neighboring branch walks a different path at once, and at the end the maze itself whispers the exit by interference.
Codes, trees, and nets.
Logos in the beginning was the word. Creation by utterance, rule-based unfolding like code executing. Sefer Yetzirah, Kabbalah, worlds formed by letters and numbers, a primordial programming metaphor. Indra's net, jewels reflecting jewels, entanglement as an ancient image where each part contains echoes of the whole. World tree, branches diverge yet share sap, quantum branches diverge yet share law. These are symbols, not mechanisms, yet they prime the mind to expect that pattern is primal, that meaning can live in structure, and that information is not an afterthought but a first ingredient.
Criticism, debate.
Many worlds is extravagant. Collapse adds an unexplained magic step. Many worlds drops it and accepts the consequences of the math. Interference already demands something else to cancel with. Deutsch's point is, we should count what our best explanations require. Quantum advantage is hype. Hardware is hard. Large-scale fault-tolerant machines aren't here yet. True, but the principle, computation by harnessed interference, defines a new class of algorithms, not just faster chips. Decoherence will always win. It's the main dragon, yes, but it's a known dragon. The theory itself tells us where to armor the knight, isolate, encode, correct, and only let the branches meet when the music cues. Isn't this just metaphysics? When machines exploit interference to do work, interference between what stops being a parlor question. In Deutsch's picture, the multiverse is the workbench, and quantum computers are the tools that make its presence experimentally useful.
Final thought.
If reality is code, then meaning is the program you dare to run. Arrange the echoes. Let the wrong notes cancel, amplify the true. If every quantum calculation is a meeting of branches, what calculation are you arranging in your life right now? What small change in the pattern would make the right future interfere with itself and shine?
The code of reality, quantum computing and parallel universes.
If reality is code, then meaning is the program you dare to run. Arrange the echoes. Let the wrong notes cancel, amplify the true. If this vision of the quantum struck a chord, help us continue. Like, share, and subscribe. And if you'd like to support Positive Vortex directly, click the thanks button or join the channel to walk further on this path with us.